Hi everyone, I am SS Kiran. I would like to discuss about short question and answers in transistor biasing and thermal stabilization. In this chapter, I would like to discuss these topics. Okay, and I will show some questions. You can understand the strength of the questions. I will read randomly. Okay, the first question is, what is the need for biasing? First question. Then fourth one, define biasing. 13th, list the advantages and disadvantages of fixed bias method. Okay, I will read randomly. At the time of explanation part, I will read a question and answer, and I will explain each and every question also. Right. 18th, define thermal stability. 22nd, draw and explain the self-biasing technique. Okay, now we will enter into the question and answers. Right. The first question is, what is the need for biasing? The two techniques are very important to do biasing. The first one is transistor can work as amplifier. Transistor maintains some operating point. These two is very important. One is amplifier, second one is Q point. By these two reasons, it's required to do biasing. Now, answer is, a transistor can work as amplifier only if the DC voltages and currents in the circuit are suitably fixed. Hence, biasing is a must. Okay. The second point, the DC current and voltage decided the operating point or quiescent point or Q point. Okay, simply it is called a Q point. What is the equation for this biasing? IC is equal to beta IB plus ICEO or beta IB plus 1 plus beta into ICBO. So need for biasing, the first one is transistor can work as an amplifier, and second one to maintain operating point. These 2 points are very important, right? Second one, write the condition for biasing a transistor to work as an amplifier. You know very well, to need for biasing to work as an amplifier. Though how transistor works as an amplifier? At active region, transistor works as an amplifier. Generally, the transistor output characteristics, we have observed 3 regions. One region is cutoff region, active region, and third one saturation region. Cutoff region, transistor acts as a off switch. Active region, transistor acts as a amplifier. In saturation region, transistor acts as a on switch. Yes. Finally, we get some distortion free output. Coming to answer, in order to produce distortion free output in amplifier circuits, the two major parameters, the supply voltages and resistances. What is the two parameters? Supply voltages and resistance in the circuit must be suitably chosen. Okay, these voltages and resistance establish a set of DC voltage. That voltage is nothing but VCEQ and current ICEQ to operate the transistor in the active region. Just you can vary input voltage and output voltage. The output DC voltage is VCEQ. Just varying the voltages and resistance in the circuit must be suitably chosen. Just suitably chosen means just you can adjust input side and output side. Okay, to operate the transistor in the active region. This is the first condition. In this region, transistor acts as an amplifier. IC is equal to beta IB plus 1 plus beta into ICBO. Okay, beta is a current amplification factor for common emitter, right? 1 plus beta is also one of the current amplification factor in the common collector. No need here. Okay. Now output side we have to write one equation that is called KVL. VCC is equal to IC into RC plus VCE. Okay, we can write some coordinates based on this equation. At VC equal to 0, then IC equal to VCC by RC. Finally VCC by RC comma 0. We get some two equations. Based on these two coordinates, we draw one line also, that is called DC load line. Next question we will discuss about the DC load line also. Yes, now quickly, third one, define operating point or Q point. How we can define operating point? Again we can start with transistor works as an amplifier at active region. Okay, again same method. In order to produce distortion free output in amplifier circuits, the apply voltages and resistance, these two parameters are very important in the circuit, must be suitably chosen. Okay, why this Q point you may observe at active region. Okay, we will see how we can observe in active region. Good. These voltages and resistances establish a set of DC voltage, that is called VCEQ, and collector current ICEQ. Why here we can call VCEQ? VCE means voltage across collector terminal to emitter terminal. Q means some Q point, that's why VCEQ. And current ICEQ means what? Output current is IC. Q point, that's why ICQ, to operate the transistor in active region. Good. These voltages and currents are called quiescent points. Already we know VCEQ, this is a quiescent value of voltage. ICEQ, this is the quiescent value of current. Okay, determine the operating point at or Q point for the transistor. Okay, we will see a diagram also, then we can understand. Yes, now here you can observe transistor output characteristics. Now we can draw graph between VCE and IC of different values of input current, that is IB. Now we can draw one line between VCE and IC, IB equal to 0. Then one more line, that is called IB1 at 10 microamps, 10 or 20 microamps. Then IB2 30 microamps and IB4 some 100 microamps. Just these are all transistor output characteristics. In x-axis VCE, y-axis IC, different values of input currents, that is equal to IB, IB1, IB2, IB3, IB4, like that. Now we can draw one line, it touches with cutoff region and this saturation region, and note some points, identify some points, just touches with this line. Now we can point out one line, then note this point, that is equal to Q1, the next one Q2. Simply join of these all points, we get one line. This line we can call it as a DC load line. Okay, at the middle of the point is equal to Q1 point. Okay, now after that these are all joining points, we get one line. This line we can also call DC load line or load line. Okay, based on these points, one more operation here, intersection of this Q point. This is one line. This is you may get in just 3.5 milliamperes and this B, and intersection point is also called Q point. Okay, now based on this diagram we can notate this Q point. Okay, actually what is our question? Define operating point. This Q point you can observe here. Okay. Now define biasing. What is biasing? Biasing means, I explained in the previous question, a set of DC voltage, that is VCEQ, and current ICEQ to operate transistor in the active region. Yes, obviously. Here you can observe there is a 3 regions. This is cutoff region, the middle one active region, here saturation region. In this cutoff region, okay, in this cutoff region and saturation region touches one line, and middle of the line we can point, that point is called Q point. How it will be get Q point? Just vary the input current and output voltage. Okay. Here a set of DC voltages, that is called VCEQ, and current ICEQ to operate transistor in the active region. So this is active region. In this active region we can identify the Q1 point. Q1 point means quiescent point or operating point or Q point. Okay. Voltages and currents are called quiescent values. Already I have discussed. The process of giving, what we can give power supplies, the process of giving proper power supply voltages and resistance for establishing the desired Q point is called biasing. Why it is called process of giving proper supplies? Here this is Q point. Just you can vary the VCC value and IC value at different values of input current, that is equal to IB2. Here you can vary the VCE, means it is one type of power supply. Automatically IC also vary. Here indirectly IB2 varies, means input voltage also varies. That's why here we can call the process of giving proper supply voltages and resistance, varying the resistance for obtaining desired Q point. Desired Q point is called biasing. Okay, clear. Now fifth question, write different types of biasing methods. Okay, types of biasing methods. The first one is fixed bias or base resistor method. Second one, emitter feedback bias. Third one, collector to base bias. We can see diagrams in next question on. Okay, or collector to base bias or collector feedback bias. Fourth one, collector emitter feedback bias. Fifth one, voltage divider bias or self bias emitter bias. Okay, these are all different types of biasing methods. Yes, very interesting question. What is the load line? Just now I have discussed load line. This is called load line. Okay, I will give it some definition, right? You can understand. Referring to the biasing circuit, the values of VCC and RC are fixed and IC and VCE are dependent on RB. Okay, RB means some input side bias resistor. Okay, input side base resistor. Sorry. Then apply Kirchhoff law. We get at output side VCC is equal to IC RC plus VCE. Okay, the straight line represented AB. This is called A and this is B. Just you can draw this graph, you may get good marks. Okay, the straight line AB is called the DC load line. How to write in some definition form? It touches saturation region and cutoff region at middle of the point is called Q point of different Q points along joining with them. That joining line is called the DC load line. Okay, good. The next, what is the stability criteria or stability criterion? Now answer is stability criterion. It indicates degree of change Here change means delta, change delta IC by delta IC naught, change in operating point due to variation in temperature, due to variation in temperature. The first, actually we can classify 3 stabilization factors: S, S dash, S double dash. S is equal to dou IC by dou IC naught. In definition part we can use one word, that is equal to change. Okay, or S equal to delta IC by delta IC naught, delta IC naught, simply delta IC naught at VBE comma beta constant. Coming to second stabilization factor, S dash dou IC by dou VBE. Okay, that equal to IC naught comma B beta constant, or S dash is equal to delta IC by delta VBE, that equal to IC naught comma beta constant. The third stabilization factor is S double dash. Okay, dou IC by dou beta at IC naught comma VBE constant, or S double dash is equal to delta IC by delta beta IC naught comma VBE constant. These 3 are called stabilization factors. What is criteria? It indicates degree of change in operating point due to variation in temperature. Okay, next video I will discuss some more questions. Finally I will complete all the question and answers. Okay, thank you so much. Bye.